Welcome back to another one of the AS statistics videos, and this time we're going on to something that is both very exciting, very new, and also something you can do entirely on your calculator, which makes it pretty fun because it's quite easy. Now, we're going to talk about the binomial distribution. Now, there are other distributions that you may come across, such as the Poisson distribution and the normal distribution. All of those can be done on calculators too. So the second I show you how to do this, your life's going to become a lot easier, which is why I thoroughly recommended getting this calculator here, the FX991EX, because it does. I'm not saying other calculators don't do it, it's just that's the one I'm going to be using, and that's the one I'm very, very familiar with. However, if your calculator is slightly different, you can probably figure it out. So, this comes right before we get on to probably the hardest part of AS statistics, which is hypothesis testing. Because in hypothesis testing, you use the binomial distribution to figure stuff out. So what is the binomial distribution? Well, probabilities in real life follow a distribution. So you might have seen a normal distribution before, it's a bell-shaped curve. So for example, the amount of people that are a certain height follows a bell-shaped curve. We peak at an average height, so something like 5'9" in the UK or something like that. And then towards the tail ends, the number of people drop off exponentially, which makes sense, right? There aren't many 7 feet tall people walking around, like there's not many 4 feet tall people walking around. So, this is just another form. It's a binomial distribution. Now, you might know what bi means. It means two, because you can only use a binomial distribution when you have two options, okay? So, to use a binomial distribution, here's what you need. First of all, you need to be able to simplify your scenario into two outcomes, which are usually something like success and fail. So heads and tails. Cool? But then you might think, okay, rolling a dice, you could never use the binomial distribution, but you can. If you have, for example, the probability of getting a 6 and not getting a 6, that's two outcomes. Probability of winning a lottery and not winning a lottery. Probability of being a certain height and not being a certain height. All of these can be the binomial distribution, but remember they give you a success fail. Yes, no. The other thing you need to know is there has to be a fixed number of trials. So that might sound a bit weird, but for example, if I'm trying to work out the probability of getting 6 heads when I throw a coin, I can't just say what's the probability of getting 6 heads, because it will be 1 if I have an infinite number of throws, or 100 throws, or 1,000 throws. So instead what you have to do is have a fixed number of throws. So I could say, what is the probability of me getting fewer than 6 heads when I throw a coin 50 times? That's valid because I have a fixed number of trials. Likewise, if I have, let's say I'm putting pizzas into an oven and I want to know the probability that out of 50 pizzas, I burn 10 or more of them. That's binomial as well. Those kinds of things. Lastly, is quite straightforward, but you need to actually know the probability of success. So you need to know the probability that we call it the probability of success, but that sounds a bit weird because it sounds like a good thing. So for example, the probability of burning pizza is never a good thing. However, that could be the success. Essentially, the way I think of it is the probability that the event you're considering happens. So the probability of burning a pizza is 0.4. That's the probability of success. I know it doesn't sound like success, but that's what it is. So now we can talk about this kind of notation here. So the discrete random variable x tilde b, what does that mean? Well, the way you read this is the discrete random variable x can be modeled as, or is approximated by, that's what that tilde means, a binomial distribution. Now this binomial distribution looks like this, where n is the number of trials. So how many times are you doing this thing? And p again is the probability of success, right? So just to read that again, the discrete random variable x is modeled as a binomial distribution, b. If it's a normal distribution, it's n. If it's a uniform distribution, it's u. If it's Poisson, it's p, etc. Then number of trials and probability of, again, success. So now I'm going to show you how to actually work out these probabilities. How exciting. So for part A, it says, can you find the probability that x is exactly equal to 5? Yes, I can. Now, if you ever see the equal sign, you're going to be using the PD function. I'm going to show you what that means right now. Because PD stands for probability distribution. Okay, so you go to shift menu. Sorry, you go to just menu. Down to the right twice and you come across distribution. Don't click statistics, although that might make sense. Distribution, because we're looking at distributions. Press equals and you have all of these options. Go down to binomial. So we have binomial CD and binomial PD. CD is cumulative distribution and you use that whenever you have an inequality. So these both mean cumulative distribution. Because remember, it adds up, okay? Now, we want PD because it's an equals. We want a precise value. So for, now list and variable. If they give you a number, choose variable. So what's X? Well, X is the value that we're looking for, which is 5. N is the number of trials, 15. P is the probability of success. I'm done. That can be a 2-mark question in an exam. Done. I've done nothing. I've done no intelligence. I've done no knowledge. Just how to use it on a calculator. Now you might think, well, can I still get marks or do I have to do some kind of calculation? Well, without this calculator, or without a calculator that can do this, you don't need to do a calculation. Instead, what they do is they give you a fat booklet which contains pages and pages of different values. So it's a massive table, and what you have to do is find, for the binomial distribution, n is 15, probability of 0.35, and then find x equals 5. It is so pointless to do that. It's a complete waste of time. But the good thing is they tend to give you 2 or 3 marks for this because of how long it takes to look through the table. So if you use a calculator, you save 3 minutes. Straight away, you're saving time. Really, really quick and efficient. So in actuality, you won't lose any marks because there's no calculation. If you look at any mark scheme, there's no calculation you do. It's just you either look it up in a table or you do it on a calculator. And personally, calculator wins every single time. It's so much better. In terms of kind of how many decimal places, well, this is kind of a test question I was giving you. So it's not kind of an exam question, although this is an exam question that could come up. It's normally going to just be give it to 3 significant figures, is what I would suggest. Now, of course, it's not all sunshine and rainbows. Instead, we do have a couple of other styles of question. Funnily enough, part C is easier than part B. Now, I'm going to do part C first, and then that might be a bit weird, but let me show you why. So, as you can tell, it's an inequality. So instead of binomial PD, we're going to go to binomial CD. Okay, and then variable. Now, in this case, you may, if you're very eagle-eyed, you may have spotted that one has an equal sign, less than equal sign. This one has a less than sign. Just so you're aware, CD only gives you less than equals to. It doesn't give you greater than. It doesn't give you greater than equal to. It doesn't give you less than. It only gives you less than equal to. So if they ask you for greater than, you have to manipulate it to give you less than equal to. As in, you need to manipulate your answer. If it's a less than, you need to manipulate it so you get your answer, okay? But for this case, part C, it's less than equal to, so now I'm just changing this to a 10. Done. 0.997. So the question is, how do I manipulate less than 4 for me to be able to use it on a calculator? Well, less than 4 is the same as less than equals to 3. Because remember, this is a discrete variable, right? So it takes fixed numbers, integers. So all I have to do is change that to a 3. Less than equal to 3 is the same as less than 4 when you're dealing with integers, right? If I ask you to write out all of the integers that are less than 4 and all the integers that are less than equal to 3, you'd write the same list of numbers. So press equals to go back, change this to a 3. Done. 0.173 for this one because it's 3 significant figures. And that's it. I'm not even kidding. This kind of question has come up before and it was worth 5 marks. Right? It's not that bad. But it does take practice. And I would thoroughly recommend that you get this calculator. Using the tables is a pain in the neck. It's not difficult, it's just tedious, and it takes a lot of practice. And the reason why I say that is because you'll know roughly where certain values are. But that's not exactly a good form of knowledge, right? So I would thoroughly recommend getting that calculator. I'll put a link to it in this post. But again, bear in mind that's an Amazon link, so you might be able to find a cheaper version in person or somewhere else online, or buy it secondhand. I'm just saying that that's the calculator that you kind of want to get. So you can probably imagine what we're going to do for the rest of this video, and if you looked at the length of this video, it's a lot of practice. We're going to keep doing this. However, of course, there's going to be different inequalities that we're going to deal with. Now, first things first, if you notice, they haven't actually given me the binomial distribution, and they haven't even said if we should use a binomial distribution. Interesting. Because part of A-level statistics, and I will say this is more A2 when you come across normal and Poisson as well, is you sometimes have to decide which one to use. Now, of course, because this is a binomial distribution video, you probably can tell it's going to be binomial distribution. So, but let's think of why. So the probability of Harry being late for school is 0.1. Over a term of 30 days, find the probability that Harry is late one time, more than 4, blah, blah, blah. So why is this a good thing to use for the binomial distribution? Well, because there's only two outcomes. He's late or he's not late. You can't be kinda late, right? It's late, not late, that's it. Cool. And we have the probability. And we also have a fixed number of days. So a fixed number of trials. So you can probably see, by the way, why the wording of the definition that I used earlier is a bit vague. Because number of trials can mean a lot of things. 30 days is technically a number of trials, and so is being late for school being 0.1, being a probability of success. So how would I write this? Well, the first thing that you write, if you remember, is the number of trials. So we're going to put 30 there, and 0.1 as our probability of success. So exactly one time, what does that look like? Well, that looks like the probability that, so I should probably put the x and the tilde, that x is equal to 1. So what we're going to use, take a second to think about it. If you guessed probability distribution PD, then you are correct, because it's an exact number of values. It's 1, exactly one time. So go down to binomial PD, or just choose that. Variable, because we know how many we want. So x is going to be 1, n is 30 now, and the probability of being late is 0.1. 0.141. Again, to 3 significant figures because they haven't really given us any other indication as to why. I will say that when we do hypothesis testing, we sometimes go to something like 5 significant figures, but you know, that's for another day. So more than 4 times, what does that look like as an inequality? Well, that looks like x is greater than 4. So we're going to use the cumulative distribution because it's an inequality, but remember what I said. We need to write this in terms of less than equal to. So how can we do that? Well, we want more than 4, right? Well, if I look at a number line, this might help me. So if I just make a straight-ish line like this, and then we put the numbers 0, 1, 2, 3. I know it's not evenly spaced. It's completely fine. How can I make this less than equal to? We want the probability that all of the numbers are greater. Well, we want more than 4. But the problem is we can only go from 0 upwards. So what we could do is work out all of these values here. So all of those values, and take it away from 1. So why 1? Well, if it's not less than 4, it has to be greater than equal to 4, right? So that means we would actually have to include this value as well. My bad. So yeah, if it's not less than 4, it has to be greater than 4. Right? If it's not less than equal to 4, it must be greater than 4. So what we're going to actually do is do 1 minus the probability that x is less than equal to 4, because that will give me the values I want. Now, when I uploaded this video to YouTube once, not this video, but another one like it, there was some confusion about using this overlap. So I'm going to write it out in a different way. We're looking for probability of x is greater than 4, so we're looking for the probability that it's 5, 6, 7, 8, ... But the problem is, I can only work out the probability from left to right. Right? So as you can see, I want to get rid of all of these values. So how can I do that? Well, if I work out the probability of getting these values and then subtract it, I'm taking it away. Hopefully that makes a bit more sense. The probability of getting all of these values is of course 1, because all probabilities have to sum to 1. So this is where things get a bit different. First of all, we need the cumulative distribution. And again, I hope that makes a bit more sense. With practice, it will make more sense. So we're going to cumulative distribution. So that's 1 variable, and we want 4. And the rest of this is the same. So we have 0.825. But remember, that's not our actual answer. So we want to do 1 minus 0.825. Now, one trick, by the way, is this is still saved as the answer button. So if I go back to calculation, I can do 1 minus answer and get the value, 0.175, which is the actual real answer. And then for part C, it says less than 3 times. So that is actually a much easier one. So x is less than 3. So that is going to be the probability that it's less than equal to 2. Because remember, it's a discrete variable. Think about it. Can he be late 1.5 times, or 1.36 times, or 10.2451 times? No. He's either late. If you count the number of lates, it's always going to be an integer. So, once again, back to the distribution, and it does usually save, and it's cumulative again. It does usually save. Oh, never mind, it didn't this time, but it does normally save the values. And n was 30, and the probability of success is 0.1. So equals a couple times, you get 0.411. Again, 6-mark question. The thing that's difficult here is definitely this middle part here. So really make sure you understand what I was doing with this kind of number line and with getting rid of these values. Okay, really try and understand where it comes from. But again, with practice, it will make a hell of a lot more sense. And now comes on to the hardest inequalities that we'll have to do, which is when they have a between sense. So here we have it's less than 7, less than equal to 7. That bit's easy to do, but then we also have to have it greater than 3. So how is this going to work? Well, once again, we can visualize this using a number line or by writing out the numbers. So I'm going to do both. So first of all, with the number line, again, let's just draw a straight line. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now the values that we want are 7 and greater than 3. So what we can do using our inequalities, because again, remember, we have to go from left to right, is we could work out less than equal to 7, which would look like this, and then get less than equal to 3. So this is the probability that it's x is less than equal to 7, and this is the probability that it's less than equal to 3, and subtract them from each other. So we could effectively do this. Minus, and that will give us our answer. Perfect, right? Now let's show you in the other way, because I'm willing to bet that didn't make full sense to everyone. So if we want between 3 and 7, here's the values that we want. We want 4, 5, 6, and 7. Now, if I just go from 0 to 7, and then match them up again, what I want to do is effectively get rid of all of these ones. So how can I do that? Well, if I work out what all of these are, then I can subtract these ones. So, in other words, I want all of the numbers that are less than equal to 7, which is why we have this bit, less than equal to 7. And I want to get rid of everything that's less than equal to 3. So I subtract less than equal to 3. Hopefully one of those methods makes sense, because these are really good for just gaining 3 marks once you understand it. Again, if this is very confusing for the first time, you've never done something like this before ever in your life. So it's completely understandable that you are a bit confused. So once again, we're going to be using the good old-fashioned cumulative distribution. I believe I was on the cumulative distribution before. Yep, Binomial CD. So I'm going to put the 7 in first. And if I remember, n is 20 and the probability is 0.41. So we have 0.380, let's just call it for funsies. And we're going to subtract. Change that to a 3. 0.013, let's call it. I know that technically that's not a significant figure, but what I'm going to do anyway is I'm actually going to round it to 3 significant figures. So 0.38 minus answer, and then I'll round this to 3 sig fig anyway, so 0.367, which turns out to be the same anyway, so it doesn't really make much of a difference, does it? And that's it. Hopefully that's starting to make a bit more sense. Again, this is the trickiest part of this whole thing. Once you get this, once you know what you're looking for, this becomes child's play. I could get a 9-year-old to do this, right? The actual putting into a calculator, right? But getting to that bit is where you actually get your marks. That's where you prove your knowledge. And it's not the easiest thing in the world. So the best advice I can give you is make it make sense. If it doesn't, leave a comment. I will help you out. Maybe even we'll do a kind of like Microsoft Teams quick go through of it, or a Discord call, something like that. I will help you understand this. But take time yourself to really break down what I'm doing, why am I doing it, and kind of understanding it there. I explain it in maybe 2 or 3 different ways, but if they don't make sense, let me know and I can help you out. One that's probably not too bad considering the last one that we just did, but the discrete random variable x is modelled as a binomial distribution with a number of trials of 30 and a probability of success as 0.58. Find the probability that x is greater than or equal to 12. So, once again, if we just draw our little number line out, and I'm going to make it a bit smaller by starting off at 8, because if you notice, we just care about greater than 12. So, to be honest, I probably should have started at 12, but you know what? Live and learn. And we want all of these values. So, in other words, we want the values 12, 13, 14, 15, and 16. And this goes on forever, by the way. And the problem is we can only go less than equals to. So what we want to get rid of is these values. So dot dot dot, we have 8, 9, 10, 11, 12, 13, dot dot dot. So we want to get rid of all these values. So the best way to do that is, simply put, just do the probability of getting less than or equal to 11 and do 1 minus it. Cool. Back to the cumulative distribution. So number 7, and then it's cumulative. Again, normally it is cumulative, but just don't get caught out with it because it isn't always, as we've seen today. And some of the questions that I've taken, you might notice is only part A, because parts B through D, sometimes E, are hypothesis testing, which we obviously haven't gone through. Now, the reason why I split it up like this is, simply put, it's hella hard otherwise. Okay? And what I mean by that is it's too much to know at one time. So sometimes schools will literally go through all of it at once. The whole thing, hypothesis testing. Are you going to learn hypothesis testing, the binomial distribution? You're going to learn all of it. That's too much. In my opinion, it's better to get a good grasp of the binomial distribution and then do the hypothesis testing. Remember, we do have time. We have quite a bit of time, so 0.985 before our exams. Take it slow. It's better to gain some. If you rush things, you'll gain a couple of marks everywhere. If you take time, you'll gain full marks in most places, which is better. Okay? You want that efficiency. You want that quality. So you have 3 more questions and therefore 3 more examples. I would recommend now going through the worksheet yourself, doing the last 3, and then coming back and checking your answers. If you haven't been doing that already, remember, this is active learning. I need you to be doing these questions as well. Or at minimum, doing them again tomorrow for yourself, seeing how much you retain. But try and do one now at least. So this one is probably a good one to do. Okay? But for those of you that have already done it, let's say company produces pens. The probability that it's defective is 0.08. A sample of 15 is taken. Find the probability that 2 or more are defective. So again, we're going to do this as a binomial distribution. What is the sample size? It's 15. What is the number of trials? It's 15. And the probability of success is 0.08. There's a 0.08 chance that a pen is defective, and we're looking for defective pens. And they're asking me to find the probability that x is greater than or equal to 2. 2 or more means greater than equal to. Now, you might be able to do this in your head now, but it's going to be x is less than or equal to 1. Because think about it. Greater than or equal to 2 means 2, 3, 4, 5, 6, 7, blah, blah, blah. So we want to get rid of 0 and 1. So that's exactly what we're going to do. Getting rid of 0 and 1 means getting rid of everything that's less than or equal to 1. So 7, and then go down 1 variable. We have 1, 5, ooh, careful, 15, and 0.08. So that's 0. Alright, maybe I'll go to 4 decimal places for this one. 0.6597. Actually, no, I don't need to do that. One sec. 6, 5, 9, 7, dot, dot, dot. And then I need to do 1 minus it anyway, so then I can round that. Perfect. 1 minus answer 0.340. Nice and easy. Technically you don't need the 0, but if you're giving it to 3 sig fig, then you do need to include the 0. Andy plays tennis. The probability that Andy will get one of his serves in the court is 60%. Again, that means you're just going to be writing it 0.6. However, you can actually put 60% in your calculator. You can even put fractions if you wanted to. Any of these will work. So you don't even need to do anything. Okay, you can just use the normal convention. Remember, to get a percentage on your calculator, it's shift and the answer button. That does indeed work. Andy serves 20 times. So we have, again, a binomial distribution. Absolutely shocking in a binomial distribution video. 20 times. 60%. Again, I'm just going to write it 0.6. And then for part I, it says exactly 15 serves. So have a think. What are we going to do? We're going to do the probability distribution. So, menu, 7, binomial PD, because we have an exact value. It says exactly. 15 equals 20 equals 0.6 equals, and that gives me 0.075. Now, if you're wondering why this seems kind of low, keep in mind this isn't cumulative. So even though there's a good chance he'll get one of his serves in, it's exactly 15 serves, which is a very specific number. It doesn't say he gets less than or equal to 15 serves or more than 15 serves. However, the next question does say more than 15 serves. So we want the probability that x is greater than 15. So once again, using your number line, hopefully you can see that would be 1 minus the probability of getting less than or equal to 15. Okay? So we want the probability of getting more than 15 serves, so we take 15 and below and get rid of it, which is exactly what that says. Now, of course, we need to change to the cumulative distribution. So 7, down, 1, variable, 15 again, so that's, the rest of this is normal, so that's fine. 0.949, but again, we're going to be using our calculator, so we don't need to be too precise. So back to 1 minus ANS, 0.051, let's call it. So there's about a 5% chance that more than 15 will be in the court, and this makes sense because he misses 40% of the time. So hopefully this is becoming a bit easier for you. And I thought I'd be kind and end with hopefully a question that is quite easy for you right now. So again, a dice can use the binomial distribution even though there's more than 6 outcomes, because if you look at the wording, it's landing on 6 and that's it. So it's either it lands on 6 or it doesn't. So again, we can absolutely use a binomial distribution. So it says here the number of times they roll it is 20 and the probability of getting a 6 is 0.4. So this question is literally just asking me to find the probability that x is equal to 5, which again, I decided to give you a little bit of a softball, just a little bit. To finish up, we're looking for PD because we want exact values, variable, so we're going 5, and it's rolled 20 times, and it's 0.4. 0.075, let's call it. There you have it. Binomial distribution. Now, if you hated this, then I'm sorry, because the next video is going to heavily focus on the binomial distribution. And in fact, a lot of these kind of part A's, we're going to be redoing them in the next video as well, because I'm going to include the whole thing, just for practice purposes. So even if you don't decide to redo the worksheets, which I recommend, we're going to redo them anyway, okay? You don't have a choice in that. But once again, I would recommend that tomorrow, within 24 hours ideally, within 48 at worst, redo these worksheets, have a look through them, and try and do them all yourself. Remember, maths is active. It's like drawing. I can tell you how to draw, but it's not going to make you better at drawing until you actually start practicing drawing. Maths is actually the same way. Okay, you need to practice it yourself. You need to get used to it yourself. I know it's very painful, but you have all the answers. You have the mark scheme, you have these videos, you have basically all the support you can ever ask for. Again, leave comments if you get stuck, and I will respond to you. But other than that, I hope you have a wonderful day, and I'll see you in the next one.